As computer science students, we use GitHub or similar version control software pretty much every day for classwork, jobs, or personal projects. You've also likely used other people's open source work that they've published on GitHub. This is certainly the case if you've ever imported libraries to use in your projects, as these are likely repositories that are publicly maintained by a group of developers. The public open source codebase and its wealth of usable code presents an opportunity for attackers to inject malicious code into your programs. Today, I'll talk about some of these dangers and how you can better protect yourself and your work against these vulnerabilities. Our first example comes from within the cybersecurity industry itself. Often, researchers use platforms like these to publish proof-of-concept exploits for vulnerabilities to benefit the cybersecurity community in finding and mitigating flaws. However, more than 10% of PoC repositories scanned in the past 4 years have contained malicious code, so let's look into it. First, the researchers used hexadecimal and base64 analysis to decode obfuscated files before performing binary and IP checks. Then, they checked the IP address against public block lists, running it through VirusTotal and the AbuseIP database. Lastly, they did binary analysis to run VirusTotal checks on the provided executables and their hashes. Here are the results of what the researchers found. After scanning 47,000 repositories total, they found about 3,000 of them existed on public block lists. 1,500 of them were detected as malicious by VirusTotal, 1,000 of them were registered in the AbuseIP database, and about 1,400 of them contained about 2,000 examples of malicious software. This means that in total, there were 4,893 malicious repositories out of the 47,000, which is more than 1 in every 10. Let's look at some examples of what these malicious repositories contain. First, we have malicious PoC for Bluekeep, which is actually a Houdini remote access Trojan, an old JavaScript-based Trojan that supports remote command execution via Windows command line. Here you can see the file on the GitHub only contains an execute command and a decoding of the malware in base64 format. Once decoded, we can see the script this file attempted to run. This adds a new dimension to malware detection, because now code can just store malicious scripts in decoded form, encoding when necessary to execute. Next, we see a fake PoC, which was actually inserted by another researcher into GitHub to verify their scan worked. That's like tossing a piece of metal into the sand and running your metal detector over it to make sure that your metal detector is picking up the right signals. This code is an example of an info stealer that collects system information, IP addresses, and the user agent. Lastly, here's a fun one that iteratively adds a malicious script to a buffer byte by byte and then prints and executes the full buffer. All the discovered vulnerabilities were reported to GitHub, but the review and removal process may take a while. The goal was not just to flag these repos one time, but to raise awareness and further development of an automated system to detect and take down these malicious repositories. Speaking of malicious repos, I'd like to touch on repojacking, a new form of attack that exploited a vulnerability at GitHub to target 10,000 packages. Here's how repojacking works. First, user A creates a repository. Consider this your average package for any library. Next, user A changes his username at some point to, say, user B. This is where the vulnerability comes in because GitHub previously did not reroute these URLs for the repositories. An attacker can now pick the username that user A previously had, clone the repository, and inject malicious code in place of the library. Then, the vulnerability can be exploited because now GitHub routes any references to this repository to the malicious version in place of the actual version. This can be used to exfiltrate environment variables that can open backdoors into your system and give attackers your API keys, cloud credentials, and crypto keys. These malicious examples dated anywhere from a month ago to 2015, so this vulnerability has existed for a while. This highlights the flaw in any long chain of open source dependencies. A vulnerability in one spot can propagate everywhere. This specific logical flaw that prevented automated redirects has since been fixed by GitHub, but there are things that you can do to stay safe otherwise. You can conduct manual review, read and scrutinize all code before you run it. You can also sandbox your code and run it in a virtual environment, especially if it's obfuscated. I'd also encourage you to use prepackaged tools like VirusTotal that analyze the binary files of your packages. And lastly, to prevent repojacking, you can update your references to protect against unwanted redirects. If you know how, you can even use the GPG keys of authentic project authors to verify repository legitimacy. GitHub is making strides though. As a result of the aforementioned reports, they recently added a direct channel for security researchers to directly report vulnerabilities in public repositories, which prevents vulnerability testers from resorting to public posts to project owners about their project's flaws. This not only creates a channel for efficient communication, but normalizes external and independent audits of code security performed for the greater good, and increases collaboration in the coding and security community. Here are my references. Thank you for listening to my cyber chat.